Okay, next one, limitations of biopotential recording systems. What are the limitations of biopotential recording system? I divided into three types. First one is signal interference and a limited spatial resolution and interpretation. Okay, let's see one by one. What is the signal interference? Okay, signal interference biopotential recording can be affected by external factors such as movement of body, electrical noise, and other sources of interference. Okay, these are the signal interference limitation. Next, limited spatial resolution. Okay, let's see. Biopotential recordings can only provided can only provide information about the electrical activity at the surface of the skin or skull. Okay, limiting their spatial resolution. Okay, next one, interpretation. Let's see what is that. Biopotential recordings require specialized knowledge and expertise. Okay, to interpret it accurately, making them less accessible to non-expert. Okay. Next, let's see the conclusion of this. Uh, Biopotential recording systems have revolutionized the study and diagnosis of various physiological conditions. Despite their limitations, they continue to be an invaluable tool in medical and research field. Next, let's see one by one. First one, I already told. Electrocardiography we already covered in last class. ECG we already covered in last class. Today's class, first one is electromyography or EMG, electromyography. Okay. Uh, Electromyography. First, introduction. What are the electromyography? Let's see. EMG is a biopotential signal that is used to measure the electrical activity of muscles. Okay, electrical activity of which organ? Muscles. The electrical activity of muscles is produced by contraction of muscles fibers, which generate action potentials. The EMG signals provides information about the muscles activity, which can be used to diagnose and monitor various neuromuscular disorders. In this session, we discuss the basic principles of EMG signals uh, generated okay, uh, basic signal generation, the types of EMG signals and applications of the EMG signals. What we are going to cover, EMG signal generation, types of EMG signals, and applications of EMG signal. First one, let's see EMG signal generation. Okay, see the diagram or see the picture. Second picture represents the EMG signal, how it represented on a recording system, how it looks like in recording system. First one is how we are going to take, how we are going to taking readings. Okay. Next, EMG signal generation. Okay, the EMG signal is generated by the action potential of muscle fibers. The action potential are generated when the muscle fibers are activated by the motor neurons. The motor neurons release neurotransmitters which activate the muscle fibers, leading to muscle contraction. The muscle fibers generate action potentials which propagate through the muscle tissues and produce an electrical potential difference between the muscle fibers and the surrounding tissues. This electrical potential difference is called EMG signals, which electrical potential difference, the muscle fibers generate action potential which propagates through the muscle tissue and produce an electrical potential difference between muscle fibers and the surrounding tissue or neighboring tissues. This electrical potential difference is called the EMG signals. Next, EMG. The EMG signals is influenced by several factors such as number of active muscle fibers, the rate of motor neurons, the type of muscle fibers, and the position of orientation of the electrodes. The EMG signal can also be recorded using surface electrodes and needle electrodes. These are the types of electrodes, okay? The surface electrodes and needle electrodes. In okay, the surface electrodes are placed on the skin or overlying the muscles, while the needle electrodes are inserted directly into the muscle tissues. This choice of electrode type, this choice of electrode type depends on the specific application and the depth of muscle being examined. Okay. Next, let's see types of EMG signals. There are two types of EMG signals. One is spontaneous and evoked. Okay, there are two types of EMG signals are there. One is spontaneous and evoked. Okay, spontaneous EMG signals are generated by the spontaneous activity of muscle fibers without external stimulation. Spontaneous EMG signals can be further divided into two types. Okay, first, see, EMG signal are divided into two types: spontaneous and evoked. The spontaneous is divided into two types. One is resting and action potential. Okay, resting and action potentials. Resting potential are generated when muscles is at rest. Okay, when muscles at rest, resting type of spontaneous signals are generated. Okay, and the muscle fibers uh, are questioned. Okay, action potential are generated when the muscle is activated, either voluntarily or involuntarily. Okay. Next, evoked. Let's see what is the evoked. Evoked EMG signals are generated by the external stimulation of the muscles or nerve that innervates the muscles. Evoked EMG signals can be further divided into two types: motor and sensory. Motor evoked EMG signals are generated by the stimulation of motor cortex or and peripheral nerve that innervates the muscles. Sensor evoked EMG signals are generated by the stimulation of the necessary nerve that innervates the muscles. Next one, EMG signal analysis. EMG signal analysis. EMG signal analysis. See this diagram. EMG signal analysis. The EMG signal can be analyzed using various techniques such as time domain analysis, frequency domain analysis, amplitude domain analysis. We already know what is the frequency, what is amplitude. Definition of a frequency, definition of amplitude. So this EMG signal analyzed in three different types, such as time domain analysis, frequency domain analysis, and amplitude based analysis. First one, the time domain analysis involves the examination of EMG signal waveform, including amplitude, duration, and shape of the signal. Time domain analysis can be used to detect the classify various EMG signals abnormalities. EMG signals abnormalities such as filtration. Okay, so like this myotonic discharges, like that. Okay, filtration are spontaneous contraction of individual muscle fibers which produce low amplitude, high frequency EMG signals. Uh, okay, next, frequency domain analysis. Okay, frequency domain analysis involves the examination of frequency content of EMG signals using techniques such as Fourier analysis of wavelet analysis. Frequency domain analysis can be used to quantify the spectral characteristics of the EMG signals, such as the dominant frequency, the spectral density, and the power spectrum frequency domain analysis can also be used to detect and classify various EMG signals, abnormalities, EMG signal and more abnormalities such as fatigue, cramps, and denervation. Okay. Amplitude based analysis involves the measurement of amplitude of the EMG signals, which reflects the strength of strength of muscle contraction. Amplitude-based analysis can be used to uh, quantify the strength, and duration of the muscle contraction, as well as to detect and classify the various EMG signals abnormalities such as muscle weaknesses and myopathy. Okay, just applications of EMG signals. Let's see one by one applications of EMG signals. First one, EMG signal analysis has a wide range of applications in the field of clinical neurophysiology, rehabilitation, sport medicine, and biomechanics. Let's see one by one. In clinical physiology, what are the applications of EMG in clinical physiology? Let's see. EMG signal analysis is used to diagnose and monitor various neuromuscular disorders such as neuropathies, myopathies, and motor neuron diseases. EMG signal analysis can also be used to evaluate the efficiency of the various treatments such as medication, physical therapy, and surgery. In rehabilitation, okay, next one, in rehabilitation, EMG signal analysis is used to assess the effectiveness of rehabilitation programs such as strengthening exercises, balance training, and gait training. EMG signal analysis can also be used to develop personalized rehabilitation programs based on the individual's specific neuromuscular and deficit. Okay. In sports medicine, let's say EMG signal analysis is used to evaluate the biomechanics of sports movement such as running, jumping, and throwing. Okay, such as running, jumping, throwing. EMG signals analysis can also be used to optimize and training program of athletes by identifying their specific neuromuscular strength and weaknesses. Next one, last one is biomechanics. EMG signal analysis is used to study the mechanics of human movement, such as walking, standing, and ranging. EMG signal analysis can also be used to develop biomechanical models of human movement, which can be used to design prosthesis devices. Okay. Okay, these are the applications of EMG signals, EMG, electromyography system. Okay, these are the applications of electromyography systems. EMG signal overall, EMG signal analysis is a powerful tool for measuring and analyzing the electrical activity of muscles. EMG signal analysis can be provided valuable information about the muscle activity, which can be used to diagnose and monitor various neuromuscular disorders, and evaluate the effectiveness of rehabilitation program, optimize the training program of athletes. These are the applications of the electromyogram. Okay, thank you.